Today we're going to cover 10-5, the distance formula. Our main idea today is to find the distance between 2 points on the coordinate plane. Also, we're going to find a point that is a given distance from a second point on a plane. In other words, if they gave you the distance, we're going to find the point. So going one way and then the other. Okay? Algebra Standard 2.0, and it's also a geometry standard for the next course, geometry. So this is the distance formula. The distance formula is the distance, d, between any 2 points with coordinates x sub 1, y sub 1, and x sub 2, y sub 2. And it is given by this formula. D equals the square root of the quantity x sub 2 minus x sub 1 squared plus the quantity y sub 2 minus y sub 1 squared. So make sure that you jot down this formula. I'm going to give you a little bit of background to this formula. Okay, for example, where did it come from? Okay, the distance formula is actually derived from the Pythagorean theorem. Okay, so I'm going to kind of give you a little background to where this came from. Okay, so basically what that means is if I have some type of line segment with an endpoint A to an endpoint B, okay, and I want to find out what the distance is from point A to B or vice versa, B to A, I can use this formula to figure it out. Okay, and it actually does come from the Pythagorean theorem. So let me show you where that comes from. Okay, now if I want to find the distance, what I could do is create a right triangle, and that is what I'm doing right now. I'm drawing them in my legs. Okay, so what I'm going to do is with this right triangle, we'll notice that it is a right triangle. Okay, it has a right angle. I need to find the length of the hypotenuse. So a couple of things. If this is my right triangle, what are the coordinates, let's say, at this point C? Well, this point C has the same x value as the point A. If you notice, they both line up, so they must have the same x. So this must be x sub 1. And you'll notice that this lines up with y for the B, so the y from the B coordinate, y sub 2, must be its y coordinate. Okay? Now, keep in mind that I am going to use the Pythagorean theorem, so I need to find the length of the legs. So how would I find the distance from point C all the way to point B? One way to do it would be to count it. Since it is flat and it is on an actual grid line, it's actually easy to count. So I could count it, but the only thing is I have no numbers on this graph, so there are no numbers assigned to this. So if I were to find it, okay, for example, and I'll do a quick example here. Let's say if I was on a number line and I had 2 endpoints, let's say right here there's an endpoint at 1, and over here there's an endpoint at 4, how would you find out how long this line is, this line segment? Well, I could count it, 1, 2, 3. Or what I could do is take 4, take away 1. My endpoint minus where my starting point was, right? So 4 take away 1 would give me the distance, which is 3. 3 spaces is how much I moved. Okay? So I can do the same thing with my graph. My endpoint here is x sub 2, comma y sub 2. My endpoint on this side is x sub 1, y sub 2. Okay, so how would I find the distance? Well, it started at this x, which is x sub 1, and it ended up at this x, which is x sub 2. So my distance would be x sub 2 minus x sub 1. My endpoint minus my starting point. Okay, and that would be the length of this leg. I can do the same thing vertically and find the distance of this leg. Same thing. I started at C, which is x sub 1, y sub 2, and then I traveled up to x sub 1, y sub 1. So what I can do here is the same thing. I'm going to travel vertically, starting here, ending here, so I actually have the difference of y sub 1 minus y sub 2. Okay? Now keep in mind that this will be the distance of each side. So now if I use Pythagorean theorem, remember what Pythagorean theorem stated, that if I have a leg squared plus a leg squared of a right triangle, I get the hypotenuse squared. Okay, so my leg here, leg 1 here, I've got x sub 2 minus x sub 1 squared, plus I've also got y sub 1 minus y sub 2 squared. And it should equal my hypotenuse, which I'm going to call it this time d. Since I don't know how long it is and I want to find its distance, we'll call this d. Okay, so it would be d squared. Okay, now if I want to find what d is, remember that we talked about mutual enemies before, that the opposite of a square root is a square, and vice versa. The opposite of square would be a square root. So how could I get d by itself? I would need to square root it. In that case, I would get a d equals, and I have to square root the other side, which gives me the square root of x sub 2 minus x sub 1 quantity squared plus y sub 1 minus y sub 2 quantity squared. Okay? Now, you'll notice something right away here as I'm doing this. The order of x sub 2, x sub 1, y sub 1, y sub 2. Okay? Now, you'll notice that they are actually in reverse. Okay? What we can do to make things easier to remember as well, since the difference of the two, it actually will come out the same, whether or not you reverse it or not. Since it's easier to remember in a certain order, we're going to go ahead and switch it back. So I could say the distance is the square root of x sub 2 minus x sub 1 quantity squared plus y sub 2 minus y sub 1 quantity squared. Okay? Because they will come out the same when we subtract it and square it. Okay? So this is our distance formula, and now you know where it comes from, the Pythagorean theorem. So we're going to jump in and do some examples at this time, okay? An example would be, here's our first example, example number 1. Okay, example number 1. Okay, find the distance between the points at 4, -1, and -2, -5. So what we're going to do, the first thing you should always do is write the formula down. Okay, I'm going to use my distance formula since it asks for distance. So the distance is square root of x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 quantity squared. Now keep in mind it could be reversed. We talked about that. It could be x sub 1 minus x sub 2, y sub 1 minus y sub 2. Okay, it'll come out the same. Okay, so now I'm going to go ahead and replace it. Keeping in mind that before I replace it, I'm going to label this as my x sub 1, y sub 1, x sub 2, y sub 2. Now I'm going to replace it. So I get square root of x sub 2, -2, minus x sub 1, 4, squared, plus y sub 2, which is -5, minus a -1 quantity squared. Be careful of this double negative here, okay? And think about what happens. Minus a negative actually becomes plus plus, right? Okay, so I'm going to further simplify. -2 minus 4 gives me a -6, so this is -6 quantity squared, plus -5 plus 1 gives me a -4. So that is squared as well. Keep simplifying. Notice I'm still inside the square root. So -6 quantity squared will give me 36, plus -4 quantity squared will give me 16. Keep simplifying, and I get the square root of 36 plus 16, which gives me 52. Okay? However, I'm not quite finished yet because I always have to simplify. Remember right here that you have to simplify as best as you can. Okay? We need to have simplest radical form. Okay? Simplest radical form. Which in other words means you have to satisfy all the conditions. No twins or no perfect squares inside the radical. No fractions inside the radical. And lastly, no radicals in the denominator. So right now, if you take a look, 52 can be factored. It's factorable. Okay, 2, which gives me 26, 2, 13. 13 is a prime. So I end up with 2 times 2 times 13. So this is 2 times 2 times 13. What can I do? I can take out my twins of 2. So I end up with 2 square root 13. Okay, and this is units, okay, as our distance. Okay. Now, we can also estimate if you wish to do so, or if the question so asks, we can estimate what this is. Okay, if I was to estimate, and if it asked you to estimate, okay, our estimate would be this. 2 times, what is the closest to square root of 13? Well, if you think about this, square root of 13 lies between two other squares. The square root of 16 is bigger, while the square root of 9 is smaller. So it lies somewhere in between. But if you notice, it is closer to the square root of 16, so it is closer to that 4. So I know it's either going to be close to the square root 2 times 3 or 2 times 4. We know it lies somewhere in between there, so it's either going to be 6 or 8. And I would say my closest estimate at this time would be somewhere near 8. So if I had to estimate, I would say that 2 square root of 13 could be somewhere close to, could be 7, could be 8. Okay? I could also estimate before I do my rounding, which would probably be a better idea. Okay? So if I did that before my rounding, I would actually get a square root of 52, which is close to a square root of 49. So it could also be 7 units. And it's now if you take a look, I've got 8 units here or 7. What do you think would be a better estimate? 8 or 7? Probably my 7, right? So if 7's better, then we notice now that we should estimate before we take out our twins, okay? So if you estimate from your original square root, you'll probably get a better answer. So I would say this is about 7 units, maybe a little bit over, okay? But this answer is still best. We call it simplest radical form, and that's what we'd like to see, okay? Okay, so it's your turn right now. Go ahead and give this one a try, okay? So I'm going to create this one as a you try. Number 1. Okay, so your turn. So find the distance between the points at -4, 2 and 4, 17. Okay, so moving on, let's go ahead and turn the tables. Let's go the other way. Suppose you know the coordinates of one of the points, okay? And one of the coordinates of the second point. That means you either have your x or your y. And you also know your distance, okay? The only thing missing then is the other coordinate that they leave out, okay? So now we're turning the tables. This is objective number 2, okay? So here's our example. Suppose you have this given information, okay? I want you to find the value of A if the distance between the point at 3, A and -4, 5 is square root of 58 units, okay? So what we're going to do is we're going to set up the distance formula again, okay? D equals the square root x sub 2 minus x sub 1 quantity squared plus y sub 2 minus y sub 1 quantity squared, okay? I'm going to fill in all of the information I can fill in, okay? So right now, I'm going to go ahead and fill in. They gave me the distance, so I'm going to fill in my distance. So my distance is the square root of 58, okay? What other information did they give me? Well, they gave me some information for the points, okay? So I've got 3, A. I'm going to fill that in. I could say that's my x sub 1, my y sub 1, okay? And I also have points -4, 5, so that's my x sub 2, y sub 2, okay? So let's fill that information in. X sub 2, -4, minus x sub 1 is 3, quantity squared, plus my y sub 2, which is 5, minus my y sub 1, which is a, quantity squared, okay? Now if you take a look on both sides, they both have radicals. So for me to start working this problem, I need to get rid of the radicals so I can get to the good stuff, the stuff inside, the radicand, okay? So I'm going to go ahead and undo a square root. How would I do that? I need to square it. Once I square it, the square and the square root cancel out, okay? So I end up with 58 equals square and the square root cancel out. -4 minus 3 quantity squared plus 5 minus a quantity squared, okay? And then I'm going to continue working the problem, okay? Notice these squares I need to figure out, okay? So, continuing with this problem, okay? Now I need to go ahead and simplify, right? So negative 4 minus 3 gives me a negative 7 squared, plus 5 minus a quantity squared. Beware, I'm going to put a big star here. This is where most people will get the problem wrong, starting at this point. Okay? Be careful. Right now, this is a binomial squared. You either need to FOIL it, or if you know your PST, you can do your PST, okay? Which is first squared, last squared, double the middle. First squared, 25. Last squared, negative a squared, is positive a squared. My middle is 5 times negative a, negative 5a. I'm going to double that, negative 10a. Okay? And then I'm going to bring down my 58 on this side. Okay, so be careful right at that point. Okay? Further simplify, I get 49 plus 25 minus a 10a plus a squared. And for me to solve now, you'll notice that I have a square term, so I have to make it equal 0 to solve. So let me just go ahead and clean this up a little bit. Okay? 49 plus 25 gives me a 74. Minus 10a plus a squared equals 58. Okay? Further simplify. Okay? So what would you do next to get a 0 here? What would you do to get 0? I would need to move that 58, right? So let's go ahead and move that 58. Now, while I'm at it, notice I want to make it equal to 0. I'm going to rewrite this in descending order. So it's a squared minus 10a. And if you do your subtraction correctly, you should get a positive 16, right? Now, how do we solve this? We need a factor. So is there a GCF? No. There are 3 terms. 1, 2, 3. First square, last square? Absolutely. So I'm going to check. A squared, this will be a 4. And if I double that, a and times 4, 4a, it will not give me negative 10a. So this is not a PST. So then I'm going to go to my X box or just simply my diamond since this is a short one. Okay, so 16, negative 10. What times what gives me 16? What gives me a negative 10? That's it. Negative 8 times negative 2, right? So now I'm going to replace. So this is a minus 8 times a minus 2. And then I need to solve for each of them, right? A minus 8 is 0. A minus 2 is 0. Add 8, you get 8. A equals 8. Add 2, you get a equals 2. Okay? So, and keep in mind that this is telling me where the other endpoint will be. Okay? So, there are 2 possibilities. If you think about this, if you have a line segment, okay, and you know its distance, it could end up in 2 different directions. Okay? That's why you have 2 different answers. Okay? So, a possible answer could be A is 8. Or I could have A is 2, okay? Or I would just write A or 2, okay? So now it's your turn, okay? I want you to go ahead and give this problem a try, okay? So this is your turn. Change that to your turn, okay? Or you try, number 2, okay? Find the value of A if the distance between the point at a comma 7 and 3 comma negative 1 is 10 units. Okay? Bring your 2 problems to class tomorrow. See you then.